No, try to say in mic rather than typing it in text form. Okay, so post processing, the word itself intimates that the process which are done after the 3D model has been printed. Okay, so in the previous lesson, in the previous session, we have learned about different parts of FDM printer along with its function. So can you say what an extruder is? Okay, what is the use of an extruder? Can someone say what's the use of an extruder? Anyone? Try to be interactive. At least this is the last session, no? Okay, fine. So each of the different component in a FDM printer plays a crucial role in the overall functionality and the quality of a printer. So as long as you maintain the good quality of each part of this printer, the efficiency of the built 3D model will be high. So in today's session, we are going to learn about post processing. We will know what is post processing in 3D printing refers to and the different methods of post processing used in FDM 3D printing. So even though, see this, the process in building a 3D model is too complicated. So we need to make sure the errors should be less. So even though we try to make sure the errors will be less, there will be problems faced in 3D printing. We'll come to know about these problems later in the session. Okay. And we'll also come to know about the applications of 3D printing in this session. 3D printing technology has many applications from the healthcare to jewelry building and even and they are even used in building aerodynamical parts as well. So let's get into post processing. The post processing in 3D printing is a critical step that transforms raw printed models into functional, aesthetical, pleasing, and industrial compliant parts. It addresses common issues such as layer lines, support marks, and rough surfaces, ensuring the final product meets the desired specifications. So, why do you think there will be layered lines on the 3D printed model? Can anyone guess the reason why there will be layered lines? So, what do you think could have caused these layer lines in a 3D printing model? Okay, we'll get to know about it in the later stage. So, when you try to build a complex 3D model, consider building a sphere. So, it won't be having any base, like it won't be having any support to be built around. So, you need to build some support structures so that the 3D model attains the stability and it doesn't distort it from its position while it's being printed. So, the removal of the support is also very important in a 3D printing process. So, consider like a complex 3D structure. Uh, Let it be a no, just make think of it as a sphere. While building sphere, the contact area of the base part is very less, so it won't be as much stable as you think. So you, in order to build a sphere, you need to build a support parts for that sphere so that it won't move from its original position, and we can get a stabilized and more precise 3D model. The support structures are necessary for printing overhangs and complex geometries. Removing the supports in the first step, removing the supports is the first step in the post processing, which can be done manually or by using specialized tools. See, it can be done manually when the support structures are like hanging outside of the given 3D complex 3D object. When the supports are inside the 3D, like in between of this model, then it will be hard to remove manual. Then we need to use specialized tools. It is important to wait until the 3D printed part has cooled down. See, if you don't wait till it's cooled down, the supporting parts in the 3D printing model will be of different materials. So if you won't let it cool down, without cooling down, if you try to remove the support particles, then there might be a distortion in the 3D printer, in the model printed by the 3D printer. So you need to wait till the whole 3D printed model is cooled down and it is fully cured before attempting to remove the supports. Removing supports while the part is still soft can lead to damage or deformation. Okay, the common tools that are used for support removal includes needle nose pillars, X-Acto knives, flush wire cutters, files, etc. The choice of tool depends on the factors like the support material, the composition of the support material, the part of the geometry and complexity of the 3D model, and desired level of precision. Sanding and polishing. So why do we do sanding? Can anyone guess why do we do sanding? It's written here only, see.
Finishing
Yeah. Continue.
for finishing purpose.
Yeah, correct. So sanding and polishing are the two of the most common post-processing techniques. These are used to improve the surface finish. So we do sanding and polishing on the to give a good finish for the given 3D model. So it involves using abrasive materials like sandpaper to remove layer lines, blemishes. But remember one thing, while using the sandpaper, it can't be used on every 3D model. The 3D models which are built by hard materials can only be rubbed with the sandpapers because these are too abrasive. Okay. It involves using abrasive materials like sandpaper to remove layer lines, blemishes, and excess material from the surface of a 3D printed part to achieve a smoother and more polished finish. So we do sanding and polishing to remove the layer lines and to give a good finish for the 3D printed object. So sanding can be done manually or with power tools like orbital sanders. For complex geometries, specialized tools like sanding sponges and needle flies may be required to reach tight spaces. So do anyone know where sandpaper is used? Do all of you guys watch cricket? So does using sandpaper
In ball
deform the
tempering.
given object? You guys watch cricket, right?
Yeah, it is used in ball tempering.
Yeah, example? When was that done?
It was done by Australian team.
Yeah, exactly. So that is why it's consider the cricket ball. It's made of cork and leather. By using sandpaper, even the cricket ball is getting distorted. So we can't use sandpaper on every 3D model object because it is too abrasive and it can lead to deformation of the object. So less abrasive tools are used compared to sandpaper. Okay. Wet sanding using lubricants like water or soapy solutions can also prevent clogging and achieve an even smoother finish. Polishing is the next step after sanding to further refine the surface of a 3D printer. So, okay, so why do you do polishing? Generally, why do you do polishing?
For
For
signing purpose, sir.
smooth surface finish.
Yeah, for smooth surface finish and to make the 3D printed object look good, right?
Yes.
Yes.
Yeah. So the polishing involves using increasingly finer abrasives to remove microscopic imperfections. So while you rub with a sandpaper or used any other material to remove the layer lines and everything. So since it is a harsh thing, there will be some deformities, like microscopic deformities will be there, where there will be like wedges and the layer will be improper. So in order to fill those gaps, we will be using this polishing so that we obtain a mirror-like finish like this. Okay. So manual polishing with polishing compounds and soft clothes, rotatory polishing with felt or cotton polishing. We'll see. These are generally this method of rotatory polishing is generally used for shoe polishing. You guys have seen that in shopping malls there will be person with shoe polishing machines will be there which will be having these rotatory motion things. Yes or no?
Yes.
Yes.
Yeah, that same technology is used in order to polish these objects. Okay. Chemical smoothing. Chemical smoothing, also known as vapor smoothing or vapor polishing, is an advanced post-processing technique used to improve the surface finish of 3D printed materials made from thermoplastic materials. Okay, can anyone say full form of ABS? I said it in the last session, the full form of ABS. At least guess know what ABS is. Okay, just
ABS is
try to
acrylamide.
Plastic.
remember the full form of ABS.
Acrylonitrile butadiene styrene.
Yeah, it's correct. Okay, then what is meant by thermoplastic materials? What is difference between thermoplastic and thermosetting? When a material is cured, the thermosetting materials strengthen and they form chemical bond within themselves, while the thermoplastic do not form any chemical bond while they are curing. Okay, so this is a thermosetting material. Okay, then what is full form of ASA? Okay, fine. ASA is acrylonitrile styrene acrylate. Okay, acrylonitrile styrene acrylate. Can anyone say what is the structure of styrene? Do you guys remember what a styrene is? Okay, it's just a benzene with an methylene group attached to it. Okay, you guys know what is benzene and methylene group, right?
Yes.
Yes.
Yeah, it's just a benzene attached with a methylene group at the top. Okay, the choice of solvent is critical for vapor smoothing process as it is compatible with the material used for the 3D printed part. So we need to select a solvent in such a way that it won't react with the material of the given 3D printing object. Okay, for ABS and ASA. Okay, now can you say full form of ASA? What is full form of ASA? I said it just now.
Acrylonitrile styrene.
Acrylic.
Acrylate, yeah, it's correct. Acrylonitrile styrene acrylate. For ABS and ASA, the most commonly used solvent is acetone. Acetone effectively dissolves the outer layer of these materials, resulting in a smooth and glossy finish. Okay. So painting and coating. Painting and coating enhance the appearance durability of 3D printed parts. Techniques include priming, spray coating, brush coating. So do you guys know what is priming? It's it's nothing, it's just a form of coating. Don't try to think too much. These methods can also add properties like UV resistance and improved adhesion. Okay. So what do we need to why do we need to paint and coat the 3D objects? What's the use of coating it?
For protection purpose, sir, like
For
corrosion is there.
appearance purpose.
Yeah, okay. For corrosion, what do you need to do? Consider if the 3D object is printed using SLS or SLM by metal sintering. So then what you need to do to the 3D project in order to coat it? What method will you use? If an object is print using SLM, you guys know what SLM is, right? Or you don't know?
Yes.
Okay, so what will you do for if consider a model is built using SLM 3D printer. So in order to coat it, what will you do?
Galvanization.
Yeah, exactly. You will galvanize the material. So what is generally done in galvanization? So why do we do galvanization?
To prevent rusting.
Yeah, to prevent rusting and corrosion and to not give direct exposure to atmosphere, right?
Yes.
Yeah. So when you print a material, if if the 3D model consists of metal in it, then you need to galvanize it in order to protect it from corrosion. So painting 3D printed parts can serve several purposes. Aesthetics. Painting allows you to change the color of a part, enabling customization. So if you paint the given 3D model, 3D printed model, so you can change the color of it however you like and design it in whichever way you want. Surface preparation. Applying a primer coat before painting helps to improve the adhesion of the top coat. So if you apply a primer coat to a 3D printed model, so the color when you try to paint it, the color lasts longer than the normal one which doesn't have primer coat. So because there will be adhesion between those two. So paint can also provide a protective layer that shields the part from the UV light, scratches and other environmental factors. So heat treatment and annealing. So heat treatment and annealing involve heating the printed part to alter its internal structure, increase its strength and durability. This is especially important for metal 3D parts. See, the materials which are being printed using SLM process, these all post-processing methods are done to these mostly. The one which are used printing SLM. Can you guys say how objects are printed using SLM? Okay, can you say full form of SLM and how SLM works?
Selective laser melting.
Yeah, selective laser.
Melting.
Yeah, how does it work?
It uses a laser beam to melt layers of powder to create a product.
Yeah, exactly. That's correct. We use the laser to melt the product and build the desired 3D model, right?
Yes.
Yeah. So annealing is a widely used heat treatment process that involves heating the material to a temperature higher than its crystallization temperature but lower than its melting point, so that we can get the desired internal structure of the given material. Okay. So common coating materials used in 3D printing post processing include resins. You know what an epoxy group is? What is an epoxy group? Epoxy is like a cyclic closed structure with an oxygen atom in it. Okay. Generally, resins, epoxy, polyurethane, and acrylic resins can be used to create a durable and glossy finish. Okay, this all just go through this once again. But remember here, silicone-based sealants can be used to waterproof and protect 3D printed parts. This is important, see. Okay, you guys know what filing is. What filling is. Why do we fill generally? Why do we use filling? Can anyone guess why do we use filling?
So that it doesn't implode or something.
See, 3D printing is not a normal process, it's a complex process. So we can't ensure that there will be 100% precision in the given model. So there will be some defects. There will be some like small minor defects like holes in the object or else the object not being as precise as it's expected to be. So in order to fill those gaps and everything, we will be using fillings. Filling is an important additive post-processing technique used to improve the surface finish and appearance of a 3D printed parts. This process involves applying a filler material to the surface of a printed part or to fill in any gaps, cracks, or imperfections. See, nothing in this world is perfect. So, in order to fill these imperfections, you need to use filling, and you need to cover those gaps using these fillings. Okay. Okay. What do you think will be the problems faced while 3D printing? What can you be the causes? Which causes? What are the causes that lead to problems in 3D printing? What can be the cause? Okay, what can be the problems faced in 3D printing? Can you get some defects in 3D printing? No,
Stringing.
stringing, exactly. So you have already read about the defects, right? Already using the technical term stringing. Still, do you know any more other than stringing? Say, no problem. Even if you know that's nothing, right? Say it.
Just a warping of layers and all.
Yeah, correct, exactly. Stringing, warping. Okay, see. First, let's talk about warping. What warping is like? You can easily identify warping as the corner of the bottom part are bent upwards. See, when there is a bend in the corner part of a bottommost layer, the warping can, this is known as warping. Okay. So these are the causes of warping. Lack of adhesion to the bed. This can occur due to excessive distance of the nozzle in relation to the base or poor leveling. See, if there is excessive distance between the nozzle and the print bed, so by the time the filament from the nozzle reaches the print bed, it might get cooled down and there won't be good adhesion between the base layer and the base layer and the print bed. So which leads to the bending of the base layer. It can be caused by insufficient adhesion from the extruded plastic as well. So basically, in order to solve this warping process, you need to use adhesives, strong adhesives such as 3D lac. Okay. Thermal contraction of upper layers, which means when shrinking pull the lower when shrinking pull the lower layers, this happens mostly with the materials such as ABS or nylon. In these cases, it's recommended to use the enclosed 3D printer that keeps the hot air inside the 3D printer, reducing the thermal contraction. See, when it is exposed to atmosphere, the top layers always absorb the moisture and they tend to cool down by themselves. And they won't be, so the bottom layer is hot, no? Which leads to heat transfer and that leads to bending in the bottommost layer. Okay. So crackling. What is cracking? We talk about cracking when the layers of parts are not well joined. See, when the layers are not well joined, there appears to be a gap between the layers which are known as cracking. There may be different reasons for cracking as well. See, the main reason for what do you think is the main reason for any defect in 3D printing? What is the most common reason for defects in 3D printing? Can any of you guess it?
Bad
Poor
layers, I think.
addition.
Yeah, poor adhesion. Exactly. See, first you need to ensure that there is right amount of adhesion between the layers. If you don't have right amount of adhesion, then the 3D printing object will get disrupted like hell. Okay. So poor adhesion between the layers. The layers do not stick properly to each other. Poor adhesion is usually caused by a low printing temperature. This can be solved by increasing the print temperature or reducing the layer fan speed. So you guys know what cooling fan does, right? What does a cooling fan do?
Cools the filament.
Yeah, cools the filament which is being extruded onto the print bed, right?
Yes.
Yeah. See, when you tend to cool, the two layers tend to stick and they tend to have good adhesion between them when they are at a certain temperature. If they go below the temperature, there won't be proper adhesion between them. So we need to increase the print temperature so that they will be at a certain amount of temperature and there will be a good adhesion. Okay. And this is thermal shrinkage. The layers stick together well, but a difference in temperature between the difference in temperature between the different sections of the part causes it to deform. See, why do you think the difference in temperature leads to deformation?
Sir, thermal stress is there.
Yeah, exactly. Because of the thermal stress, which can cause some layers to separate. The best solution is to use. So, in order to save these all from everything, you need to. I said in last session, right? Why do we use closed frames than open frames? Do you guys remember it? You guys remember about frames, right? Open frame, closed frame.
Yes.
Yeah, this is the use closed frames than open frames to maintain a consistent temperature inside 3D printer. See, the excessive temperature. Wait, cracking. See, the excessive temperature in motors or drivers. The electronics are not designed to operate continuously at a very high temperature. See, what do you think will it take to build a normal 3D object? So, what do you think will be the time? How long does it take to print a, say, like a your favorite Pokemon or something? How long do you think does it take? Just guess some random
It depends
times.
upon size, sir.
Yeah, okay. Just think of like your favorite anime character or your favorite Pokemon. How long do you think it takes to print a small, like a normal size? Like guess the size of the laptop adapter. Think of your favorite anime character or your favorite Pokemon. Size of a laptop adapter. How long do you think it takes to print it?
At least 2.5 or 3 hours.
Yeah, yeah, 3 to 4 hours. Okay. So do you think these all motors will be in work, right? So even see when you try to use your electronic device for continuous 3 to 4 hours, they tend to heat up, right?
Yes.
Yeah, they'll heat up. So even these motors are as well heat up when you try to print a 3D object. So we need to ensure that they are not continuously at a very high temperature so that there will be good extrusion of the filament and we can get good quality of 3D print. Okay. The lack of power in motors usually caused by a very low voltage value in the drivers. We need to check, we even need to check the motor's voltage value and give it a correct current input. Okay. And this mechanical failure is like a common thing. Okay, now from here, my friend Chaitanya will continue.
Okay. Hello everyone. I'll be continuing from layer shifting here. So layer shifting is a problem which occurs in the form of displacement on on an axis at certain height. It happens in x-axis, y-axis, and both the axes together simultaneously. And it is the why layer shifting happens. Can anyone say? Why do you think layer shifting happens?
Because of misalignment.
Sorry?
Misalignment.
Yeah. Incorrect slicer settings. When you are planning to print when you're planning to print something, when you don't put certain and correct amount of parameters in your settings, layer shifting happens. And X wobble is one of the sub. Can you just give me a minute? I have a problem here. Yeah. So a part of layer shifting happens is Z wobble. It happens in the Z direction, as you can see in the second picture here. The surface of the outer surface and all the surfaces are completely unaligned and really imperfect, right? So this happens. This happens due to the structural failures in the machine construction and due to the nozzle moving very fast, because it will not have time to catch up with the speed, and the layers are not cooled down by then. So all these are the reasons for X wobble and layer shifting happening. So proper checking of tightening the axis and proper checking of the settings and checking if the machine is properly assembled and maintaining the perpendicularity of your print bed and ensuring there are no loose screws. These will eliminate the problem. Next, stringing. Here you can see in the picture between this structure and this structure, there are thin threads appearing. So this happens because when hot end is moving between one structure to another structure, the heat, the small amounts of plastic which drip out of the nozzle will create these threads, and it is also caused due to inaccurate settings in the slicing process. So the ways to minimize these are reducing your temperature. If if the if you are having stringing issues, the temperature of your bed might be too high or the nozzle might be too high. Uh, Cracking happens because the temperature was very too low, and stringing happens because the temperature is very high. So you have to be very careful maintaining the right amount of temperature while setting up your print. So retraction distance. This is used to reduce the pressure on the nozzle by pulling the filament out of the hot zone during movements. Bowden 3D printers require 3 to 6 millimeter retraction distance, and while direct drive 3D printers use 0.5 to 2 retraction distance. So, and again, retraction speed. So the higher retraction speed, lower the stringing happens. So values between 40 and 60 usually work. Overheating. So this is another major problem we can see. As you can see, the edges are really uh, you know they're raised up, and they're melted, and the center part is really sunken in the between. So this happens because the bed temperature and nozzle temperature might be really hot, and it did not get time to cool down. So proper fan speed and proper temperature are important. To solve this problem, you have to have low temperature and increase the layer fan speed. Next, elephant foot. Here you can see it generally occurs in the horizontal axis. You can see here the first layer in the second picture. You can see it is having uneven arrangement, uneven printed bit. This happens due to your not leveling of the print bed. That's why leveling is very important. You've learned it in G code, right? Does anyone remember what is the G code for bed leveling? Does anyone remember what is the G code for bed leveling? Auto homing and G leveling. Auto homing and G leveling, bed leveling. So G29 is the G command for bed leveling. If you don't remember, just brush up on those things. So this happens because the nozzle is too close to the print bed, or the print bed temperature is very high. So you have to be careful while setting up your settings in the printer. So applications of your 3D printing. 3D printing these days is a very rapidly increasing technology, and has become a part of various industries like engineering, design, consumer products, aerospace, education. Medical has a really wide applications of 3D printing, and fashion, of course. And there are many applications of 3D printing these days. 3D printing enables us to have intricate details in your model, and customized and cost-effective products. So we'll see some of the main applications. Healthcare. So you can see how a human's part can be printed, 3D printed here. So the appreciable part of this is they can be customized, and you can take the prototypes of human what and take care what are the exact needs of them. So they're used in prosthetics and orthotics. The limbs, custom prosthetic limbs and orthotic devices can be 3D printed, which can perfectly fit the patient according to their own comfortable zone. Yeah. And implants, such as if they had an accident, uh, if the skull is like damaged or something, the the 3D printed metal sheet can be replaced there in place of the bone, which is equivalent to the bone structure, and it helps a lot. And anatomical models, as I've told right now. Aerospace and automotives. So 3D printing, as you know, the material of 3D printing we generally used is PLA right now. So, and the materials are very lightweight, and you can have more personalized and efficient designs. And aircraft parts are printed, and Airbus is having integrated 3D parts into their aircraft for reducing weight and fuel efficiency. And customized tools which are used in the aerospace and automotives can be 3D printed to reduce your costs. It becomes very economical. And automotive components such as fuel drain pipes. In Porsche, the fuel drain pipes and seat belt buckles are printed. to avoid the unnecessary weight on the passenger. So this is the part of airplane printed, uh, and this is some inside part of a automobile. Consumer goods, used in the fashion industry, footwear, jewelry, eyewear. Footwear, Adidas is printing midsoles of the Futurecraft 4D sneakers to optimize the cushioning and performance. Jewelry, jewelers are opting to 3D printing because of the intricate models which you can create with 3D printers, and they are generally not possible in traditional methods. Eyewear. Eyewear, again, it is a personalized product could be printed according to their comfort, their style, what they want. Yeah. So this midsole is printed you're using DLP printer, and these are the specs printed eyewear personalized, and this is the jewelry printed, and every all jewelry is not printed like this. It's just some jewelry is like this, and some will be printed metal, some gold is used. Every type of material can be printed in 3D printing. And one of the most important is a construction makes in construction the 3D printing is used because the time constraint is very reduced. Printing and a lot of man force required is reduced. The accidents happening during that time, everything is reduced to minimum. So that's the reason 3D printing is rapidly growing in construction. Concrete 3D printing, large 3D printers are used to build houses and buildings, and addressing house shortages, construction waste is reduced a lot. And customized elements in architecture, like cascade panels and building components, can be 3D printed to meet design requirements. See, you can see the large 3D printers printing and these layer heights between the walls and all. So this is this first India's first 3D printed houses in IIT Madras. It is it is completed in just 21 days. So you can imagine, for example, if you take a rough estimate of this house being printed normally, how many days do you think it will take? Anyone? A rough estimate?
6 to 8 months.
6 to 8 months, or 1 year, 2 years, if the builder is neglecting printing and all. So this house is printed in just 21 days. It is personalized, and it is durable, it is strong, and everything. So that's the application of 3D printing. So yeah, here we come to an end. You can mark your attendance.
Please give the link also.
Yeah. Karnya, can you please share the link?
Yeah, one moment.
Is that house in IIT Madras?
Yeah, it is an IIT Madras. You can scan the QR code and also give your attendance.
Oh, can you provide us the PDF of last two class and this class also?
We'll ask the last two classes, and this classes will be shared.
Okay.
I hope everybody has scanned. I'm stopping screen share. So yeah, with this we come to an end of the course of 3D printing. I hope you've learned a lot of interesting topics and useful and productive things. And if you have completely listened and carefully monitored and done all the assignments and learned everything, you're ready to print a 3D you are ready to handle a 3D printer. So thank you everyone.
Can someone review the whole 7 sessions? Like, how did you feel about these sessions?
Yeah, someone share their experience. They
Share
would
your
love to.
opinions. And how did you find our teaching to be? Was it good or was it bad? Or do we need any improvement in it?
Yeah, give your feedbacks. How interactive you want us to be. Everything.
Someone, at least now this is the last time we might be meeting. So at least try to be interactive.
We'll tell you about certificates. I mean, you'll get them, I guess. You'll get the information later. Yeah.
We definitely learned a lot, and even from the first day itself, I could understand every single thing. That was so good. Thank you so much.
Yeah.
Thank you.
Even others, we try to be interactive.
Yeah, this is the last session.
Yeah, this is the last session. At least be interactive now.
I also like the pop quiz in between in Slido. That was so fun.
Thank you.
Yeah, we'll share about the assignment later in the WhatsApp group channel.
How did you find our teaching and how is
So,
it? How is
is there
it?
any scope of improvement in our teaching? Please do speak up, guys. It's the last session, right?
It it'll help us also knowing what have we done, maybe improvements and mistakes.
I don't really have any improvements, but I think when you take this was an 1 hour class, but in some classes we went beyond 2 hours. Probably you could have given us like 10-minute break in between to like refresh ourselves instead of sitting continuously for 2 hours.
Okay. So maybe actually the session is planned to be 2 hours, and maybe they wanted more time, and that might be some software session, I guess, right? Some Blender or Fusion 360 sessions might have.
Yes,
Yes.
it was Blender
Yeah,
software.
yeah. So Blender software again is a very advanced software, and confining it in 2 hours completely is a very big task. So that's why they might have extended some time. So
So, about the guy who is asking for an offline visit. So, do you stay in Chennai? Okay, actually, even we are not in campus now to show you how 3D
yeah,
printing club goes and how are the 3D printers and how do they work. We are in our home as well.
He was asking a virtual visit.
Yeah, virtual visit, but there's no one in campus to show you.
You'll
Even we were, yeah, we
okay.
will go like, even we will be
Uh,
having workshops from July 9 to July 29.
so maybe we will film a
Maybe
video
we
or
might try
something.
from July
Uh,
29 to August 1st. We might try.
you'll have this WhatsApp community group already, right? It's not like it'll get deleted or something. So we'll try shooting a video or something and post it in that group. Yeah.
So please do follow IITM 3D Printing Club in Instagram, okay? Yeah, we will share videos of it. Don't worry. I guess there isn't any link, but when we go to campus, we'll shoot it and share it to you in the group, okay? Okay, so fine. Thank you guys for joining this session. We can end the meeting now.
No, wait. Uh, I didn't get your question. What about accessing? Can you unmute and ask? Accessing 3D printer.
Like suppose anyone going to IIT Madras for some research internship or project internship. So then it will be interval of 2 to 3 months now. So then in that 2 to 3 months, can we access the 3D printer? Like if we want to do some project with the 3D printer, is it
Uh,
possible?
Yeah,
I
if you
guess
get
you'll
a
need a permission from
from
the
CFI.
yeah C5. No, not C5. You'll have 3D printers in workshops now.
But I don't think the workshops one are used for printing. Yeah, even I don't know correctly.
Yeah,
I guess there will be, you need to get some permission to get access to them.
yeah. You need permissions to get access to them. 3D printers generally they'll give a permission to workshop only, I guess. Uh, you cannot come into C5. We'll post the assignment today in the WhatsApp group.
So you are talking about internships. Which year are you in? So which class are you studying in? Just finished 11th and thinking about internships. We just completed BTech first year. Even we aren't thinking about any internship opportunities. Don't think too far ahead, okay?
But we will definitely share if there is any opportunity, something like that.
Yeah, we will share.
Anything funny you want to share? Anything
Yeah,
at all?
yeah, share whatever you want. Even it might be away from the subject. Apart from subject, you can talk about anything you want.
Yeah, it's a free session today.
Yeah, we will share those. Yeah, I'll share just a minute. I'll share it now.
Wow, that is nice. Pratik,
Yeah, it's good.
that's great.
See, Hyperloop project is there's a competition team known as Aveshkar Hyperloop in IIT Madras. So do for even they have a WhatsApp channel, right? WhatsApp community channel, Global Hyperloop Competition. Yeah, do if you want to know more about Hyperloop with about the Hyperloop from IIT Madras, just go to Aveshkar Hyperloop. See, its name is Aveshkar Hyperloop.
Will you elaborate your question? Yutanshi 100.
It's Aveshkar Hyperloop. AVESHKAR. Wait, I will share it.
I have a question. Totally unrelated.
Sure, go ahead and ask.
Can jo- can MTech students join the clubs you are in?
I don't think so. Till now, I didn't find any MTech. There weren't any MTech students, right?
No, only BTech.
Yeah.
Maybe, I guess there's no restriction or something. You can join, but generally they don't join. I think so.
Yeah, I've given permission to all who have given the request. Did everyone got it, right? Everyone got the access, right?
Yes, yes.
Yeah. Yeah, can you request for the access so that I can give it? I don't know how to spell your name. Sorry if I'm wrong. It's SIJ23EC. Okay, please don't try to call me sir. Even I am a 23 student. Okay, so do you mean by 23, are you graduating in 23 or you have started your college in 23? Yeah, same. Even we have also started our college in 23. Even we are not that old to be called as sir and ma'am, okay?
And also, this is our first time taking sessions.
Yeah. Even we don't have too much of experience taking all these sessions and interacting with people and so on.
Yeah, preparing slides, everything, starting meeting sessions, conducting. Everything is first time for us also.
I don't think so. See, there's nothing related to go-kart, but there is something related to Formula One racing. It's known as Raftar.
Yeah.
Once try to search about Raftar, Raftaar. I don't think the spelling is correct. Wait, I'll check and say.
No, correct only.
Raftar, that's it. So how many of you want to join IITM? So do you guys know about IIT Madras?
Anyone giving JE this year? Or given
Or have
JE this
given
year and waiting for.
and or joining IIT Madras? Is anyone here?
No, we are BTech students, not MTech students.
Yeah, here BTech. I guess MTech won't be involving in all this stuff. They might be
Yeah,
preparing for internship and job opportunities and higher studies as well.
yeah. We are all BTech students, not MTech.
Yeah, even we have completed our first year just in May, that's it.
Yeah. Yeah, great. Uh, I am from aerospace engineering branch. He is from electrical branch.
Yeah, every club of IITM is good. It's like you will get to learn new stuff in it.
All this is apart from your academics. It's like co-curricular activity.
See, you can ask any doubts about IIT or any random related stuff, anything. It's not about only session and 3D printing, that's it. We can answer you anything.
A generic AMA session.
So, did you guys join any other C5 club summer school as well.
How are those classes going on? Those assignments?
Horizon. Oh,
Yeah.
you're interested in astronomy and everything.
Yeah, they have
Robotics club. Yeah, I guess they will be having a what? I guess every club in C5 will be having a WhatsApp channel, right?
yeah, they have.
So I guess they will be having one. I don't know exactly. Okay, so what are they teaching in Horizon? Okay, my LinkedIn ID.
My LinkedIn ID.
There's nothing much in it. Just
It's not very great.
okay, we'll try to share. Oh, they are teaching about machine learning as well. Good. So still did anyone of you join AI club, programming club, electronic club? So how are they teaching in adapt it's in programming club, right? Yeah. So what were they teaching in adapt? So did you get to learn any new stuff by going in adapt? Okay. So was there a guy named Arjun Krishnaswamy teaching in AI club? Oh, okay, fine. So they were teaching about recursion, linear regression, right, in AI club? Okay, did they complete linear regression as well? Or did they teach till depth or they were teaching on surface? Okay, so they were not teaching in depth, theory in depth, right? Okay. So did you feel like did you learn anything?
Or was it all gibberish?
Because AI club had the most registrations.
Yeah.
That's why I'm asking it. How are they teaching? How was the strength in AI club? Like how many were like consistently attending? Like a random number, 150
Like
plus
50
attendees.
plus.
Oh, good. So were they giving any assignments like were they interactive as well? Or they were like randomly teaching and going on and okay, a lot more like gibberish. Not
Not
interactive.
interactive. Did you find
Yeah,
us
they
interactive?
Sorry?
Did you find us interactive?
Of course you did.
See, every year do join these clubs because instead of like at least we'll be giving an hour or two in a day, right? At least we'll get to learn new topics instead
New
of
things,
wasting whole day.
productive. Yeah. All these are
Even
your summer holidays, right? Yeah. Which assignment? Which
which one?
assignment number are you taking about? Blender is a lot time back, right? I don't think they'll extend, but we'll surely ask about it.
We'll surely ask them. So any more questions?
Any more questions? Any more?
So any more queries? Any more anything do you want to know?
LinkedIn ID.
Please don't call us sir and ma'am. Okay, we have
Yeah.
completed just 1 year in BTech. That's it. I stay in Karnool.
I'm from Vijayawada, Andhra Pradesh.
So any Telugu people here? Yeah, we'll
Yeah.
share.
We'll share.
Okay,
We'll
wait.
share. Okay. This is my LinkedIn. Okay, cool. Grew up in Bangalore.
So you can understand Telugu. Can you speak in Telugu? So which college are you from?
నువ్వు ఎలా ఉన్నావు నేను
నేను
బాగున్నా
బాగున్నా.
ఓకే where are other guys from? Where are other people from? Oh, West Bengal. Yeah, we do watch movies. We watch a lot of movies.
Yeah, we waste time like hell. If you come to Insta, you can see how much we'll waste time.
Madhya Pradesh. Great.
See, this is my LinkedIn profile.
No, I don't watch much Malayalam movies. Only Telugu, Hindi, English.
So do you guys watch cricket? I've seen the World Cup final yesterday. I mean, day before yesterday. So it was too good, right? So which cricketer do you like the most? Last three, I think the whole match was amazing. Any Rohit Sharma fans?
Dhoni, yes.
No, Tala for a reason.
Yeah, Tala for a reason. Dhoni is the best.
No Rohit Sharma fans.
Sad.
Me, I am Rohit Sharma fan. Big fan of Rohit Sharma.
Yeah, true.
Why do you guys always try to take credit to Dhoni? He was just sitting in front of TV and watching the match. Please don't give
Right
it
now.
7 runs victory as Tala for a reason.
Rohit Sharma didn't bring World Cup. Dhoni brought World Cup to India.
Everything belongs to Tala, God. Still, any more questions?
Vishnu Mishra. I have never seen you interacting. If you are comfortable, can you speak or chat or something?
Still, do you have any more questions?
If not, we'll end the session.
Yeah, if not, we'll end the session.
Okay, we'll wait for 2 minutes and end the session if you don't have
Yeah.
any. Yeah, and thank you for staying all these
Yeah, thank you for
sessions.
staying this long.